quick tool talk. First off, super uncomfortable for me to talk about kind of offensive tools. I play defense. It doesn't mean I don't understand the basics of offense. I can Nmap and netcat and all that stuff, but like totally out of my comfort zone. But kind of makes sense to talk about the basics of how you steal data using DNS. And I've never done it, so it kind of scared me a bit. So I want to walk through that, maybe do a real small demo. Nate is remote, Nate Subra, but he helped. So he's got the C2 server set up. I've got a little client set up. We'll play a little bit. Sound like a plan? All right, so DNS tunneling with dnscat2. So I was kind of dubious this was a real thing, meaning like how bad can it really be? I've heard you can, steal data using ICMP and whatnot, but I'm sufficiently afraid. So, it's obligatory to have a silly picture in all your presentations, I think. So I thought this one was pretty interesting, definitely not OSHA compliant. And so I found this one on the internet, and it's from a guy in Northern Ireland. And I thought this was pretty funny. He said his wife had a bad snore on her, and after watching Shawshank one night, he decided to do something. So he built a tunnel from his house out to a pub, and he used it for years. And I thought that was kind of an interesting metaphor. And I'm not kidding. He did this, and as far as I can tell, it was legit. So I'm like, well, that kind of sets the stage here. It's a tunnel from your house to exfiltrate alcohol, and then bring it back without your wife knowing. So I thought that was kind of interesting. But what we're really talking about here is how do you restrict or protect access to the internet's phone book? And this stuff's stateless, right? We're talking UDP, DNS, not the TCP zone transfer stuff at this time. And you really can't. Like, I can do egress filtering. James just mentioned egress filtering to TCP 445 for CIFS. You really can't do that with DNS. And we'll talk a little bit about how recursion plays in here. So, all right. And that's the logo. That's the dnscat logo. I thought that was kind of cute, so I put it in there. They don't use their logo prominently. You got to dig in their GitHub repo to find it. So it's called dnscat2. A gentleman who works at Google wrote this in his spare time. It's not a Google project. He's got a blog. It's not just another version of netcat via UDP53. It's a full reverse shell. The server side has windows. It has commands built in to manage sessions. It does full TCP tunneling. It has baked in crypto. I'll talk about that in a little bit. And like full-on VPN. So it is like pretty robust. So let's say you did have egress filtering. Nope, no one can do outbound UDP53. You got to go to one of my DNS forwarders, and those things will then relay it for you. This thing works right through that, no problem. Like that's just a frickin' proxy to this thing. So like that's kind of scary. We'll talk about that. So then it gets even a little bit worse. There's a full-on PowerShell client from Black Hills Information Security. So if you don't want to use his client, which is written in C, you can use just native PowerShell sitting there and use that as a client, which is kind of scary because PowerShell is everywhere. So where did the name come from? Anyone here use netcat before? NC? Like really old tool, but it's like a Swiss Army knife. All right. Totally useful. Well, dnscat kind of makes sense. So there's an old version. It was written in Java, and it hasn't been touched since 2005. So this guy wanted to fix that. He called it dnscat2. So let's kind of see how this sucker works. All right. So there's the GitHub repo. It's a client-server pair. So the client is written in C, which means it's fast and dangerous, kind of like the Green Bay Packers offense. I grew up 20 minutes from Lambeau Field. If you listen closely, you'll hear a Wisconsin accent come out. There's very few dependencies. It's meant to be portable. There's an alternative client with full parity in PowerShell, provided the server side has no caching enabled, and that's from Black Hills Information Security, and they've got that there, so that's cool. What is the server written in? It's written in Ruby, which is fine. It's like Japanese Perl to me, whatever. It's what all the hipsters use. So the crypto in this thing isn't a joke. So I traced it really quick. The gentleman, Ron, who has his blog, Skull Security, understands crypto really well. So it uses Salsa 20, which is a very robust stream cipher, elliptical curve, Diffie-Hellman key exchange, the SHA-3 family. There are nonces built in. He's using a crappy random number generator, so that's my one dig. Ruby's binding to OpenSSL is in user space, not kernel mode, so it's not a cryptographically secure pseudo-random number generator because it doesn't get entropy from dev-urandom. Anyways, if you want to know more about that, you can go check out different languages and where to find randomness. So it's still pretty darn good. Like, you're not going to crack this. It's just get better randomness. So how does he do like auth? Okay, you've got a client, you've got a server, how does that work? There are pre-shared keys in the client-server arrays. They're just words, long words. So that's how it works. You pull it down. So how do you install the client? It's dead simple. You pull it down, you run make. I'm assuming you're on a Unix or Linux machine. If you're on Windows, he actually has really good detailed documentation on how to pull it down to Visual Studio, or if you're running, what's that, minimal Sigwin, you can do it there. So he's got really good instructions how to do it. On the PowerShell side for the client, you can see it's right there. Of course, everyone's going to crack the PowerShell. Permissions wide open, so you can run whatever you want. Import the module and run it as a commandlet. So it's kind of scary. How do you install the server? It's a little bit less portable because the guy really focused on getting the client right. But I didn't do that. Nate did this and it worked just fine, using Ruby gems and the compatibility to get that thing installed. And then you can go ahead and run this thing using the Ruby interpreter, and it runs just fine. So Nate and I were playing with this yesterday. We kind of decided to do this talk yesterday. So we wired it up from my laptop, went ahead and ran the compiled C, did a ping, and that's all we're going to do today, and I'll explain why in a second. This ping is basically a diagnostic test. Can I get out to nosecurity.fyi, which is the C2 server that Nate Super set up? And the answer is yes. And there's different types of DNS traffic that's going to happen. Text, CNAME, MX records, those are different flavors of DNS. And it gives you basically a response, yep, it's a valid dnscat2 server. Remember I mentioned the server as instrumentation to manage sessions, quite frankly do a reverse shell. So we wired this up pretty quick, and that isn't like a hobby laptop. I use that to get work done, and I don't want anyone touching this thing. So I was not going to have Nate go ahead and open a shell on my laptop and say, hello, Ben. It's not going to happen. You know, Nate's a nice guy. He shares a haircut like me, but he's not getting a reverse shell on my laptop. It's not going to happen. I'll do the demo last, so if it fails, it's like, oh well. But like, how do you mitigate this? I mentioned this thing works over DNS, and it works over filtered DNS just to your resolvers. So these are a number of mitigations that Nate and I put together, some from inspirations online, some from just what can you do? And I'm sure some are missing, but this is scary stuff. So what can you do to mitigate this threat? So limit the number of hosts allowed to egress DNS. So contain the pain a bit. And I think you should be doing this anyways. And then you got to watch your logs. You do collect them, right? They're really useful. You should be collecting those. I'll leave it there. Just do it. All right, so what can you do? You can analyze the query length. I don't know if I'll fire up Wireshark and show you, but the actual pings, you'll see it's very long records that's looking up. Much longer than normal with relatively high entropy on the front end. So you could do a Shannon entropy calculation on that, or just look at lengths being abnormal. You can monitor the frequency of DNS queries from specific hosts. To me, it's pretty bursty traffic. If one machine is just going nuts, like that's an anomaly. Why is that happening? All right, you can check for specific or uncommon query types. You're probably not going to run an MX lookup all the time. You do that if you're going to check for an organization's mail servers. Why would you do that all the time? It doesn't make sense. All right. DNS spikes using NetFlow or Bro, and then there's some other ways to detect anomalies. Nate threw these in there and they make a lot of sense. Skyline and Rita, I've not wired either of those two up, but they would be another layer on top to help you do some detection. You might get away with some protocol inspection with your next generation firewalls or proxies, but that's a big maybe. I didn't do any testing, but pretty sure you can get away with it. You could use clean or secure DNS service. I won't go into a lot of vendors, but there are vendors that do this, who will basically, you send DNS to them and only them, and they'll do some cleansing for you. They may look at anomalies. They may look at phishing botnet destinations. They may look at why are you resolving this weird stuff. I mean, you could have a vendor help you, right? You're not in this all by yourself. You could block the basics. So like if you have a really super new domain, do you really need ever use in your enterprise hit the domain that's 6 hours old? My answer to you is probably not. So you could block that. I do. So it's got to be 24 hours or older, I think. Something you could do. What else? Dynamic DNS, I don't know, as an enterprise, do you really need to be using or resolving and consuming content from dynamic DNS-based hosts? I don't really think so. Or you could just monitor the endpoints. Like that PowerShell that's going to run, I would think, and this is where I just play defense. Most adversaries, maybe the really advanced ones, they're going to probably be lazy, or the script kiddie's lazy, and just run this PowerShell. So you could probably find that out, because it's got a pretty well-known signature from what Black Hills Information Security published in the repo. Or you could look at your endpoints. What kind of DNS traffic are they emitting? Why is it different than normal? What is this brand new process that's sourcing outbound DNS queries that's not something you've seen before? So there are ways you could do detection, but the mitigation isn't, none of them are really great. Like there's no real silver bullet here. So there's that. All right. So wish me a lot of luck here. What I have in front here is my dirty desktop. I apologize. So over on the right is the C2 server. It's a little box Nate set up. It's called Test dnscat. We've got a session running inside of tmux. I didn't know what that was. I learned what that was today. I used to use Screen. I'm kind of old school, so it works just fine. We're going to attach to that. And then over here, I've got a little client. And all we're going to do is some ping back and forth. And that ping will reflect just the beginnings of what this thing can do on top of, underneath the tunneling or whatever else. Come on. Awesome. And we didn't set up keys, and the password's super long, and I don't want to enter it. Okay, we're going to imagine. We're going to imagine. So this is one ping that I did earlier today with Nate. Cool, it has my internal DNS server's IP in there. That's awesome. Oh well. So I did a ping to nosecurity.fyi. It went through my DNS server. It didn't go straight to the host, right? It went through my normal DNS resolver, which then goes upstream, actually to DNS cleansing service, but we won't go into that. And then it makes its way over to Nate's server. Nate's server, I don't even know if I have my buffer, but had a session running right here. You can see it was running the Ruby interpreter and then running dnscat2.rb. And it had, let me see if I have anything in my buffer. Do I? Nope. Awesome. But it pinged back and forth. I had Wireshark going at the same time, and you can clearly see outbound connections going to this thing, and they're talking back and forth. So it was really easy to establish traffic. What do you then do next? On the server side, you have windows. Different windows with different hosts. You go ahead and get a reverse shell. You can do port forwarding. You can run SSH over this thing. So I guess I share that to say this stuff's real. I am not an offensive security professional. I play defense, and I was able to wire it up in a couple hours in between meetings. So that says the barrier to do this is pretty low. Once an adversary is on your network, that's pretty bad. So they're going to find a way to get the data off. It just shouldn't be this easy is my final point here. So I'm going to pause or kind of stop, actually, since I had a big fail here. But do you guys have any questions? What I did? What's up with this stuff? Fire away. Yep. Yep. So Nate's not here. I'm going to channel Nate. If Nate plays offense, I play defense. So Nate's not here. I think he's out in Manhattan or something. So that's one he brought up, but he said it's super noisy. Either him or Tom. I forgot who was chatting about it. So Tom's the one who suggested this one because it's more robust, is from what I would understand. And you're right. The other one seems to be super noisy. This one just seemed, I don't know, man. So this is the one that we set up. There was another one we were playing with that was written in Perl, which is near and dear to my heart. But we didn't play with that one either. But that would have been cool. So I didn't run the tunneling very long at all. In fact, I got scared, right? This is my laptop I get work done on. So that's why I'm like, nope, this is far enough for the talk tonight. This is just a quick tech talk on like a tool. It was a combination of MX lookup, CNAME, and something else when I was doing the pings. So it's going to probably rotate through. I don't know if there's an affinity or if it like does any process tuning, like, oh, CNAME records fly, but MX is taking, I don't know. But it does like a combination of those. It doesn't just stick with one. So I would say this would be harder to detect. You'd have to do more math versus like flat out signatures on like, or thresholds on like null, looking up null records or whatever. Yeah. So I'm using a service, starts with ends with Brella. So I hate to say I pushed the easy button, right? But part of it in this case is to have a provider help me with that. So in that case, they do some of that cleansing, heavy lifting for me. And inside of the portal, you check a box for new domains, and that's just done. So that's dead simple. How would you do it if I had to roll my own? Have to think about it, but as you resolve domains, you could then, like, after that, have a separate process that's not a blocking process to look like how new is that thing, and then make a decision based on your instrumentation, your network, to say yay or nay or whatever else. But you can look up how old a record is based on its information in the authoritative record. What's up? Yeah, it'll work, but like, I have to key in this like long password, and I don't want to do it. How about this? Afterwards, if you want to see me play back and forth, come by. We'll do it at break. I think that's probably a better use of time. Otherwise, I'll just make myself look like more of a clown. Anything else? Okay. We're going to take a small break. Maybe Tom and Nick, how long